Right. Now we will talk about electrophiles and nucleophiles. Electrophiles and nucleophiles. Electrophiles and nucleophiles are reagents, intermediates in chemical reactions. They are intermediates in chemical reactions. Sometimes they may be existing in the neutral form, or some of them may be non-existent in the sense that the life will be very short. Okay. That is, let's look at the electrophiles. Electrophiles are electron-loving species. Electrophiles are electron-loving species. Electron-loving. They like to accept electron. Okay. They like to accept electron. You can have this into two classifications. One is neutral electrophiles. Neutral electrophiles. And positive electrophiles. Electrophiles and positive electrophiles. Electrophiles which are positive. That is, they should be electron deficient. That is why you have a positive charge. And neutral electrophiles inherent, there will be some sort of total polarity in the molecule. A positive nucleophile. What are the examples you can take of H plus is the simplest positive electrophile. H plus can accept a pair of electrons to form a bond. Okay, H plus is a very good positive electrophile. Then you have Cl plus, Cl plus, Br plus. You wonder how you get Br plus. That is preparation of these electrophiles. You require a certain chemical reactions to be performed. Like if you want to generate H plus, what do you have to do? You have to put HCl into hydrogen chloride gas, you have to pass through water. Or you take a little sulfuric acid and add solvent, add water. Add sulfuric acid into water. Okay. So that is how you have a separate method by which you can generate electrophile. Certain electrophiles, this is CS3 plus. Most of the species with a positive charge, CS3, tertiary butyl group. These are called electrophiles. All these are electrophiles. Now, how can you think of generating these electrophiles? Okay. In the case of H plus, you take water and add HCl. You get H3O plus. Plus Cl minus. Why don't we look at Cl plus? Cl plus is known as chloronium ion. Chloronium ion. Okay. And chloronium ion is an intermediate in the, it is an intermediate in Friedel-Crafts alkylation reaction. Friedel-Crafts alkylation reaction. Okay. Now what you should know, now in Friedel-Crafts reaction, Aluminum chloride is as a catalyst, act as a catalyst. Can you draw the structure of aluminum chloride? What's the formula? AlCl3. Aluminum which belong to which group in the periodic table? Which group? Sodium. What is the next one? Magnesium. Then comes aluminum. So it is in group 3. In the third group. So aluminum belongs to the third group. That means its valence electrons, there are 3 electrons. There are 3 valence electrons. Now, each chlorine will contribute. Aluminum chloride is AlCl3. Each chlorine forms a bond with the Cl. Now, this molecule is neutral now. The molecule is neutral. But you can see here, the aluminum is having only 6 electrons in outermost orbital. It is having only 6 electrons. And therefore, aluminum chloride, this itself can act as a electrophile. So what happens is, aluminum chloride reacts with the chlorine molecule. And reacts with chlorine molecule, and this undergo a bond fission. Undergo a bond fission. Okay. And what it forms is, see here, this Cl with this pair of electron is attached here. So you will get Al. Now see, aluminum has formed a 4th bond with this chlorine. So this pair of electron is shifted here. So aluminum as such gets 1 extra electron, so negative charge. And what is the corresponding species from here? That is Cl plus. So this is how Cl plus is generated. Cl plus is one which is having 3 lone pairs and 1 empty orbital. The second one, so now Cl plus, and this Cl plus is used in the chlorination reaction of benzene. Is intermediate in the chlorination reaction. Similarly, we can generate many other Br plus also similarly. How do you generate CH3 plus? Yeah, again the same method. You take the corresponding alkyl halide, react this with aluminum chloride, again the same procedure. AlCl3 and see. CH3 plus AlCl4 minus. AlCl4 minus. Okay, so that is formation of Cl plus. Similarly, you can form CH3 plus. Similarly, you can form other these electrophiles. Say for example, another electrophile is NO2 plus, nitronium ion, NO2 plus. Okay, there is interestingly, this is a positive electrophile. This can be made from a mixture of sulfuric acid okay mixture of sulfuric acid and nitric acid. If you generate, this will give HSO4 minus plus H2O plus NO2 plus. Make sure that whenever you draw this type of an equation, you make the charge equal on either side of the product on either side of the equation. So this mistake is always bound to be there. Actually, how this happens? Can anybody draw the? Do you know how to show the mechanism of this process in which NO2 plus is generated? Why don't we try that? Now, first of all, you can draw the full structure of H2O so far. I don't know how many of you don't know that. I don't want to waste the time. So this is sulfuric acid and nitric acid, HNO3. So HNO3. See here, there are 4 bonds on the nitrogen, so it should get a positive charge. Okay. And oh, I made a mistake here. Yes. With 2 lone pair of electrons here. And 3 lone pair of electrons here. With a negative charge. And nitrogen should carry a positive charge. So overall the molecule is neutral. You can see the number of bonds and all this. You should be very careful. Okay. Now, see here, this lone pair of electron can attack this. What happens? Now this bond, remember on hydrogen is having a single bond. Yes. What is the result of this? All of you write in your book before I write it on the board. Come on. OH. Oh, sorry, O minus. See that it becomes negatively charged. And what happens to nitric acid? That's H N plus N O O H it becomes. Okay, N plus N O O H. is a positive charge. Yes. Now we can think of elimination of a molecule of water from here, which will result in the formation of H2O plus NO2 plus. No, one second. This goes here. Yeah. Now this, okay. Now when you move the electrons in this fashion, the proton is lost from here, OH is lost from here, that makes the water. NO2 plus. The plus charge is on the nitrogen. Okay. Plus charge is on the nitrogen atom. And you have two oxygen on, like I said, this is called a nitronium ion. Nitronium ion. That is also stable, intermediate in the reaction. Okay. So this is, now you can, very similarly, you can try two molecules of sulfuric acid. And if you do in the same fashion, you can see that SO3 comes out. Okay. You can work it by yourself, and this is a neutral electrophile. Neutral electrophile. Okay. So that is, now you have still more electrophiles like acetyl electrophile, which we will discuss in our next session. Okay. Thank you.